Ladies and gentlemen, this is your March Reachback. March Madness, we'll call it. Ah, that's a good name for it. We'll call it March Madness Reachback with all 5 chapters that you've learned so far. Chapter 2 was on rational numbers. Chapter 3 was on exponential form. Chapter 5 and Chapter 7 were on polynomial addition, subtraction, as well as multiplication and division. And Chapter 8, the one we just finished, was on algebra. So this is a mixed medley of all of those different chapters. And the first one, we start with rational numbers. It says, without a calculator, solve 2.8 negatives plus 1.43. So without a calculator, when you're combining integers, if you're having negatives and positives and you're combining them, what you really want to do is find the difference between what you have more of and what you have less of. In this particular one, I have positives and negatives. I'm combining them by adding them. I have more negatives. So difference means subtraction. Since I only have 2 significant digits here, I'm going to add a 0 to make it 2 significant decimal digits. And I'm going to subtract. I'm going to borrow. I get 7. I get 3. I get 1. So when I subtract 2.80 or 1.43 from 2.80, I get 1.37. That means I have 1.37 more negatives than I do positive. So your solution is negative 1.37 without a calculator. 1 point for the correct answer and 1 point for showing the work. So question 1's worth 2 points. Question 2, again, it says without a calculator, solve this one. So again, probably the easiest way that most of you did it is you added the opposite. Right? So instead of subtracting 3.22, you're going to add a negative 3.22. And in this case, we're adding negatives and negatives. So really, we're not looking for the difference between the positives and negatives. We're looking for the sum of all of the negatives combined. So this one's much easier. We just have to add these together, right? 10, 3, 5. So your solution to this one would be a positive 5.3, or if you want, a positive 5.30. Pause. Oh, sorry, negative. Sorry, thank you. Right, not working. Negatives. Because you're negatives and negatives. Question 3 says, without a calculator, solve this question. So if I estimated, it would be negative 5 times a negative 2. So my estimation would be a positive 10. Right? If I estimated rounding to the nearest significant whole number, 2 points as well, yeah. Question 2 is worth 2 points. I would estimate it to be positive 10. So therefore, if I drop the decimals, I don't need the decimals anymore. I can just multiply these two numbers out without decimals because I know afterwards, since my approximation was positive 10, I can place my decimal accordingly. So the algorithm is multiply 1 by both significant digits in your above. So 1 times 7 is 7, 1 times 4 is 4. Then skip a line and do the same thing again. So I'll put a 0 down to skip a line. 2 times 7 is 14. 2 times 4 is 8 plus 1 is 9. 7, 8, 9 is your answer by multiplying those together. Since my estimation was positive 10, the only place I can put my decimal to make it relevant is there. So therefore is equal to a positive 9.87. 2 points for that. 1 point for the answer, 1 point for some kind of algorithmic work. Question 4, this time we're estimating without a calculator. Now remember what we said before. This is the money you have, and this is the size of the pile. So when dividing with decimals, you can think about money every time. I have $10.25. Ignore the negatives, so you don't need to worry about it. And I'm dividing it into piles of a quarter. How many piles of 25 cents can you make from 10.25? Well, since you can make 4 piles with $1, you can make 40 piles with $10, and you make 41 piles with $10.25. So therefore, your actual calculation, because it's not an estimation, is 41. Now, since it's a negative divided by a negative, my calculation will be positive. For question 4, you just need to have the answer of 41, right? Because you should have been able to estimate it without a calculator. But if you used a calculator, you got it right anyway. So it's one of those questions that I'd like to ask you that without a calculator and just in front of me, but the answer for that one is a positive 41. Question 5, without a calculator, solve this question. So again, We have two operations this time. We have addition and we have division. When faced with more than one operation, we need to apply the order of operations to our mathematics to solve it properly. I have $4.50 divided into piles of a quarter, just like the last question. I can make 4 piles with $1. I can make 16 piles with $4. I can make 18 piles with $4.50. That will be a negative because it's a negative divided by a positive, and my sign rules say opposite sign. So 2.5 plus negative 18 is what that's going to be for my second line. Here we have the difference of integers with positives and negatives. What do I have more of, positives and negatives? So the difference between the negatives and positives will be how many more negatives I have. So it would be 18 take away 2.5. Put a 0 there. Borrow, because I can't do it. 7, 5, 5, 1. The answer is 15.5. Is that going to be 15.5 negatives or 15.5 positives? Negatives, because that's what I have more of. So therefore, my answer is negative 15.5. 1 point for sensible work. Since it's a BEDMAS question, that has to exist somewhere. But it's 2 points. 1 point for the right amount of work and 1 point for the correct answer. Question 6, we're getting into our square roots, which is our chapter 3 on rational, squares and square roots. So we have the square root of two fractions, and both of these fractions are perfect squares. Remember, the square root means what number multiplied by itself gave you 1/9, meaning what fraction multiplied by itself is equal to 1/9. If we think about the numerator, 1 times 1 is 1, and 3 times 3 is 9. So therefore, the square root of 1/9 is equal to 1/3. If I apply that same logic to the next one, the square root of 4/25, what fraction times itself is 4/25? The numerator would be 2, the denominator would be 5, and therefore the square root of 4/25 is 2/5. So when I simplify both square roots, I get 1/3 plus 2/5. Now I have to add them together. This is a grade 7 question. Common denominator is 15. Equivalent fraction, equivalent fraction. Once you have them written, add your numerators, keep your denominator. Your final answer, it's 11/15. We'll make this worth 2 points at your discretion. 1 point for appropriate work and 1 point for the correct answer. This should be what I see for sure. If I see that, give them 2 points, right? That's what I'm looking for 2 points. Question 7, we have the subtraction of two rational numbers in mixed fraction form. The easiest way to approach any mixed fraction operation is to change them to, or mixed fraction is to change them to improper. So 1 1/2 is 3/2. Take away 13/4, which is what 3 1/4 is as an improper fraction. Common denominator is 4. Equivalent fractions is this. Now here's where a lot of students might get mixed up. You must subtract your numerators and keep your denominator, which means your final answer is negative 7/4, because 6 take away 13 is negative 7, which makes it negative 1 3/4 as a final solution. So probably that's the expectation of work. Probably all of that exists somewhere on their paper. 1 point for the work and 1 point for the correct answer of negative 1 3/4. Now, if they kept it as negative 7/4, is that right or wrong? Is negative 7/4 an acceptable answer? Yes, it is. Because it is negative 1 3/4. They just left it improper. If I was a teacher and you were a teacher and we were trying to say, you'd say, make sure you change it back to mixed fractions if possible. But that's your answer. Question 8 is the division of mixed fractions. Same rule, always easier to change them to improper fractions. When dividing fractions, we learned that the easiest way to solve them is to multiply by the reciprocal. So the reciprocal of 3 1/4 is actually 4/13. And once we have that, multiply our numerators to get 12, multiply our denominators to get 26. Realize that's not in lowest terms. And in lowest terms, our answer would be 6/13. Is 12/16 or is 12/26 wrong? No. you'd say to the student, make sure that you acknowledge that that's not lowest terms and try and express all fraction answers in lowest terms for continuity's sake. 2 points. 1 point for work, 1 point for answer. Question 19, using a number line, approximate negative 11. So when we did this, the two perfect squares that would be sandwiched between negative 11 are the square root of 9, which is 3, and the square root of 16, which is 4. So the square root of 11 exists somewhere around here, I would suggest, which therefore is approximating 3.3 or 3.2. One of those two answers is correct. 1 point for the number line with the proper benchmarks at the end, so they need to have these. And 1 point for, I'll even accept 3.4 if they had it. 3.2, 3.3, 3.4. If they had 3.1, whatever. Not right. Yeah, no. One of those answers is fine. That's worth 2 points as well. Next question is a little bit more difficult, but the exact same idea. Here we have the square root of a rational number. Actually, it's an irrational number, square root of 15. So the square root of 0.09 is 0.3. Because if I think, what's 0.3 times 0.3? So 0.3 times 0.3. Oh, clear. 0.3 equals 0.09. That's one end of your benchmark. And 0.4 would be over here, which is the square root of 0.16. When we approximate where the location of 0.15 would be, we would say it's there, which would make this approximately, the square root of 0.15 is approximately 0.38 or 0.39. If they had 0.37, that's fine as well. I'm okay with that. But one of those two is probably your best guess. 1 point for the appropriate number line and 1 point for the appropriate guess of 0.38 or 0.39. Question 11 says, how do you read this power? Now, the reason why I didn't read it is because I want to make sure we differentiate, and we said this probably about 2,000 times. This statement right here. Negative 2 squared is not the same as that other power. How do I read the other power? I read it as the opposite of 2 squared. So this particular power is negative 2 times negative 2, which is a positive 4. And this one, you can think of it as the opposite of 2 squared, which is 4, which would be negative 4. Or you could also think of it as a negative 1 coefficient to that. Either way you think of it, your standard form value is negative 4, and the way you read it is the opposite of 2 squared. 1 point for this, and 1 point for this. Our next questions get into our power rules, our exponential form rules. When multiplying two powers that have the same base, in this case a 5 and a 5, the rule is keep your base and add your exponents to give you the answer of 5 to the exponent of 6. Here's why. 5 squared is 5 times 5 times, I'll use the time signs there, 5 times 5 times 5 times 5. So when we think about this, it's really 5 multiplied by itself 6 times. Rather than write this out every time, we simply use the shortcut rule to get your standard power form of 5 to the exponent of 6. 1 point for just 5 to the exponent of 6. No work necessary. It would have been nice if they showed this, but they didn't have to. When dividing, the rule is keep your base and subtract your exponents. So your final answer is 10 to the exponent of 7. And why that is, it's when I think of this question as the division of two powers, it's 10 multiplied by itself 10 times divided by 10 multiplied by itself 3 times. And if we cross reduce this out, I really end up with 10 multiplied by itself just 7 times. And that's why the exponent rule works. 1 point for question 13 for the answer of 10 to the exponent of 7. Oh, I made a mistake with 14. It's the same one. In 15, we have a power to an exponent. If we think about what this would be, it would be negative 2 cubed multiplied by itself twice, or this here, which would be negative 2 times 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 negative 2, or negative 2 to the exponent of 6. The rule is keep your base and multiply your exponents. So therefore, it would still be your answer. You don't need to show this work. because you remember it, and you remembered that was the solution for how to get it as a single power. 1 point for negative 2 to the exponent of 6. Question 16 is the sum of two powers, and here we just have to change it to standard form. The opposite of 2 squared is negative 4, and negative 3 squared, Andrew, is... That's right, positive 9, Andrew, thank you. Yeah, and once you have that written, the sum of those two, negative 4 and positive 9, makes a positive 5. So your solution is positive 5. Question 16 is worth 2 points, 1 point for that, and 1 point for the answer. Now, a good question was asked was, why is this going to be a positive 9? Well, negative 3 squared means negative 3 multiplied by itself twice. And a negative times a negative is a positive. So therefore, negative 3 squared is going to be a positive 9. But the first one, remember we said that this is not equal to this in our previous question. This is the opposite of 2 squared. Since 2 squared is 4, the opposite of that is negative 4. And that's why the answer is 5. 17, define the parts. A is called a power, or I will also accept exponential form. B is an exponent, and C is a base. Just because I want to see you guys be successful in this, that question 17 is worth 3 points. 1 point for each of those. Question 18 says 3 quarters to the exponent of 3, which means 3 quarters multiplied by itself 3 times. 3 times 3 times 3 is 27. 4 times 4 times 4 is 64. Your final answer is 27/64. Alternatively, you could have applied your rule and rewrote it like that anyway, which would still give you 27/64. But either way you did it, 1 point for any type of work, either like the first or the bottom, and 1 point for the answer of 27/64. Question 19, we're getting into the addition, or chapter 5 on the addition of polynomials. When you're adding two polynomials or multiple polynomials together, you simply have to gather like terms. If we think about what this would have looked like as a drawing, 4x squared would have been this, negative 3 would have been this, 2x would have been this, and positive 5 would have been this. So if you think of this pictorially, that's what it would have been. Since the first ones are going to be your x squareds, I'm going to gather those first. There are no other ones to gather it with. They're done. I'm going to gather my x's, which is my next highest degree next. They're done. And when I gather those three with those three, it makes a 0 pair. I'm left with a positive 2. You don't need to draw it, but your solution for 1 point is 4x squared plus 2x plus 2. If they had 4x squared plus 2 plus 2x, what would you tell them? Make sure you always reorder your terms of your simplified polynomial in descending degree of terms, meaning the highest degree terms first, the second highest degree second, and so on and so forth. Yes. Right, but you could still give them a point for that, even though... Oh, yeah, sorry. There you go. Question 20, we have a 7-term polynomial. It just says simplify. I'm going to gather my x squareds first. 2x squared and 4x squared is 6x squared. And a negative 10x squared makes a negative 4x squared as my first term. 4x and 4x is 10x, or sorry, 8x. 8x and negative 10x is negative 2x. I only have one constant here of negative 3. So your answer is that. If they had this, it's okay as well. If they had this, that's okay. But on a test, your teacher might say, make sure you reorder them in descending degree of terms. This is the best answer, but the other two are not wrong. They're just not finished. Let's go 1 point. Let's make it 3 points for this one, just because I can. 1 point for that term, 1 point for that term, 1 point for that term. Actually, let's go back. Let's make this one. No, never mind. We won't bother. All right, here we go. Next question. Here we're adding a binomial to a binomial and subtracting a trinomial. So the first thing I'm going to do is I realize when I subtract polynomials, I like to use adding the opposite, just like I did with integers. So I'm going to rewrite this question as this plus the opposite of this polynomial, which is a negative 3x squared, a negative 5x, and a positive 1. Now that I have it as just addition, I can just gather like terms. What terms should I gather first, Aiden? Right. Incorrect. The x squared is correct. So negative 3x squared is just one of them, so I'm going to keep it as negative 3x squared. Negative 2x and positive 2x make 0 x's, and a negative 5x is left by itself. A negative 3 and a positive 1 is a negative 2. A negative 2 and a positive 1 is a negative 1. So your final solution for 3 points is negative 3x squared for 1 point, negative 5x for a second point, and negative 1 for a third point. Question 21 is worth 3 points. Those three terms can be in any order. It doesn't matter. That's the best order because it's descending degree. Question 22 is now our chapter 7 on multiplication of polynomials. We're going to multiply each term of the trinomial by the monomial. If you wanted to write it out again, 2x squared is going to be multiplied by negative 2x. Negative 4x is going to be multiplied by negative 2x. And negative 1 is going to be multiplied by negative 2x. When you simplify this, you get negative 4x cubed. Remember, negative 2 times x times 2 times x times x. That's what x squared is multiply the coefficients to get negative 4. Multiply your variables to get x cubed. Plus 8x squared would be your second term. Plus 2x is your third term. We'll make question 22 worth 3 points as well. 1 point for that, 1 point for that, and 1 point for that, in any order. That's the best order. I can't see how they'd have it in a different order. That's probably what they're going to have. So 3 points for that question. Question 23 is the division of a trinomial by a monomial. And Andrew, you know that when you divide, each term of the trinomial or polynomial must be divided by the monomial. So 6x cubed will be divided by negative 2x. Negative 2x squared will be divided by negative 2x. And negative 20x will be divided by negative 2x. When I work that out, dividing the coefficients will give me negative 3. Dividing x cubed by x will give me x squared. Negative 2 divided by negative 2 is 1. I don't write 1 coefficients, but it will be a positive 1. And x squared divided by x is x. And negative 20 divided by negative 2 is a positive 10. And x divided by x cancels each other out. My final solution for this is negative 3x squared plus x plus 10. 3 points for that. Each term is worth a point. Question 24 gets into some abstract thinking a little bit, because it's not saying just do this. It's actually asking you to use your brain and apply your addition of polynomials and your multiplication of polynomials into one question. What's the perimeter? So the perimeter, as a formula, is made up of 2 lengths and 2 widths. You don't have to have it as that. You could have just side plus side plus side plus side. That's fine. If you did that, you have 2 sides that are 2x plus minus 1, and you have 2 sides that are x squared. When you expand this using distributive property, you get 4x minus 2 plus 2x squared. That is actually the perimeter, but a smart person would reorder those terms to make it 2x squared plus 4x minus 2. Either one of those perimeters is correct. This is worth 3 points. Each term is worth its own point. That term has to exist, that term has to exist, and that term, or in a different order, is fine as well. But the solution for the first part of 24 is worth 3 points. The second part, your area equals length times width. It doesn't matter which you put your binomial, which one your monomial is. I always like to keep my monomial as my first term, so I'm going to make this the length as opposed to this. It doesn't matter. and 2x minus 1 will be my other one. Using distributive property, x squared times 2x is 2x cubed, and x squared times negative 1 is simply a negative x squared. So your solution for 2 points is the area equals 2x cubed minus x squared. So question 24, therefore, is worth how many points? 5. 3 points for this, and 2 points for this. 5 points. That was a tough question-ish. Question 25, we get into the algebra component. We have a two-step algebraic equation with a coefficient and a constant. Always get rid of your constant first if you can. Negative 5x equals 3.75 negatives. Divide by negative 5. And x will equal 3.75 divided by 5 equals 0.75. So your answer is going to be a positive 0.75. 1 point for that work, 1 point for that work, and 1 point for the correct solution. 3 points for question 25. And question 26, your last one. There are 2 ways to do it. I'll show you both. The first way is to reimagine the question. Like this, probably. And then you're going to multiply both sides by 8. Perhaps. When you expand this, you're going to get 6x minus 4 equals negative 15, if you did it properly. Added 4 to both sides, you get 6x equals negative 11. And if you divide both sides by 6, x equals negative 11/6, or negative 1 and 5/6 as the solution. That's if you did it that way. Alternatively, you could add a half to both sides. So let me just get this over here. Hang on a second. If you add a half to both sides, you get 3/4 x equals negative 15/8 plus multiplied by 4, 4/8 would be negative 11/8. Divide by 3/4 to get rid of the multiply by 3/4. But dividing by 3/4 is the same as multiplying by what? Dividing by 3/4 is the same thing as multiplying by 4/3, which you get x equals negative 44/24, which is negative 1 and 20/24, which is equal to negative 1 and 5/6. That question's worth 3 points. 2 points for work that's sensible, and 1 point for the correct answer of negative 1 and 5/6. If my math is correct, I think it's out of 56.